Sorry that some disconnectivity problem was there. Hello, hello.
Yes,
Yes,
sir.
sir, you're audible.
Yes, sir. Audible,
Okay,
sir.
okay, okay. So for diagrams with Markov chains assumption, we give it like a probability of x1 followed by x2, x3 like that up to xt, that is equal to probability of x1 into probability of x2 given x1, probability of x3 given x2 into like that probability of xt given xt minus 1. So if it is trigrams, then how do we do it? Probability of x1, x2, x3, x4 like that up to xt is equal to probability of x1 into probability of x2 given x1 into probability of x3 given x1 followed by x2 into probability of x4 given x2 followed by x3 followed by x3. Okay, so this is the way how you have to go through. So here we ignore all the history but consider only the recent state and the next state if it is a bigram one. Okay, so observing the sequence of symbols, the sequence of states that led to the generation of the symbol is basically hidden. So that's why we call that one as a hidden Markov model, right? So this HMM basically comprises of the following terms or following tuples, you can say that, like Q gives the sequence of states and O can be represented as sequence of observations drawn from the vocabulary, and Q0 and QF or Q0 and QF as we say is like the start and final states of the automata or this Markov model. A is the transition, this is state transition probabilities, and B is the symbol emission probabilities. For this particular transition, what would be the emission of this particular symbol? Okay, that is B is the symbol emission probability. So if you are in a certain state, what is the probability that you are going to emit a certain symbol from that particular state while doing that transition? Okay, that is what we call it as emission probabilities, and pi we represent as the initial probabilities. So the earlier thing, like the sequence of states or the sequence of observations, the start and final states or the initial and the final states, all these are common with respect to a finite automata, but the additional things, okay, here for only the transition thing, like how the transition takes place, here A, B and pi are important. That's why for a HMM basically we represent this one like a complete probabilistic model. If you see A, B and pi, A is the state transition probabilities, B is the emission probabilities, and pi is the initial state probabilities. So let us see this with an example. Let's talk about the weather that like we have three types of weather. For example, sunny weather, rainy, and then foggy. Okay, sunny, rainy, and foggy. So let's assume for the moment that weather lasts all day. It means that if it is sunny throughout the day, it will be sunny. If it is rainy throughout the day, it will be rainy. And if it is foggy throughout the day, it is foggy. So that is our assumption. Okay, we assume that when a weather is occurring at the morning, it means that till end of the day, the weather remains same. Okay, so it doesn't change from rainy to sunny or maybe like a foggy to sunny or foggy to rainy, like that in between. Okay, that's what our basic assumption is here for this example that we are seeing in. Okay, so weather prediction is all about trying to guess what the weather will be like tomorrow based on the history of the observations that we have taken about the weather. So let's assume a simplified model of weather prediction. So we will collect statistics on what the weather was like. Like we are mostly interested in finding out what was the previous history of the weather. Like suppose we say that yesterday was rainy, today was foggy, then and tomorrow what would be the probable weather. So based on the earlier previous history, we are interested in finding out the next day's weather. Okay, so let's assume a simplified model of weather prediction here. We will collect statistics on what the weather was like today based on what the weather was like yesterday, the day before, and like that forth, and like so forth, before, like that, about the previous histories. So here we need to understand one thing, that we are interested in collecting the weather of previous days. Okay, previous days means yesterday, day before yesterday, and the day before yesterday, and few days, 2 days before, day before yesterday, 3 days before, day before yesterday. So like that, the complete history is to be required. So we are interested in collecting the probabilities, like probability of it is, so that can be represented in an equation like this, right? Probability of W1, Wn given Wn minus 1, Wn minus 2, Wn minus 3, like that up to W1. It means that from the first day, the historical day, which we started counting from the first day up to yesterday, we are interested in getting the statistics. So using the above expression, what we can do, that we can give probabilities of type of weather for tomorrow and the next day using n days of history. For example, if you know that the weather for the past 3 days was like this, like it was sunny, then means one day it was sunny, second day it was sunny, and the third day it was foggy. So assume that in this chronological order it is available. So the probability that tomorrow would be rainy can be given by the following equation. Okay, if you see the equation 2 here, we can give like this. So probability, so first day you see W1 was sunny, W2 was sunny, and W3 was foggy. So that is what we are trying to give it. So probability of W4, the fourth day is equal to rainy, given first day is sunny, second day is sunny, and third day is foggy. Or in other words, we can give it like this: probability of W4 equal to rainy, given W3 equal to foggy, W2 equal to sunny, and W1 equal to sunny. So these W1, W2, W3, or W3, W2, W1, we can give in any sequence, that is not a problem, but you have to follow only one order, either from ascending or descending we need to follow. Please make sure that. Okay. So here, for example, the problem is, the larger the n is, the more statistics we must collect. It means that it should be available. Suppose that n is equal to 5. Then what we should do? We must collect statistics of 3 power 5, because the 3 variables like rainy, sunny, and foggy, and up to 5 days, different combinations. That is something like 243 past histories we need to find out. So therefore, we must make a simplifying assumption called the Markov assumptions. Okay. So in this, for the sequence W1, W2, W3, Wn, like that, it can be given as Wn given probability of Wn given Wn minus 1, comma Wn minus 2, comma Wn minus 3, like that up to Wn 1, or approximately we can give like this also, if we are interested only on the bigrams. So it can be given as probability of Wn given Wn minus 1, means one day before history. Suppose yesterday was foggy, what would be the today's weather? Yesterday was sunny, what would be the today's weather? Yesterday was rainy, what would be the today's weather? That is what we are interested in. So this is called the first order Markov assumption. So we say that the probability of an observation at time n only depends on the observation at time n minus 1. Because of this, we are interested in bigrams. If we say trigrams, we are interested in n minus 1 and n minus 2. If it is quadgrams, n minus 1, n minus 2, n minus 3, like that we are interested in. If it is 5 gram or like pentagram, then n minus 1, n minus 2, n minus 3, n minus 4, like that we are interested in. So so that when the order increases, so a second order Markov assumption would have the observation at n time n dependence as n minus 1 and n minus 2. That is for trigrams. So in general, when people talk about Markov assumptions, they usually generally they talk about first order Markov assumptions, that is nothing but the bigram models. Okay. So here we can express the joint probability using the Markov assumptions as like this, equation 4. I hope it is visible to you all. Probability of W1, W2, W3, like that up to Wn can be given as like the product of all I equal to 1 to n up to n terms, okay, probability of wi given wi minus 1. It means that you are interested in finding only bigrams, the product of all the bigrams in a sequence. Okay, probability of occurrence of the first term, then second term given the first term, third term given the second term, fourth term given the third term, fifth term given the fourth term, like this, ninth term given the eighth term, like that. Okay, you are interested in finding out. So now let us see, if you see how many histories that we are interested in. So it can be like we now only 3 power 2, that is equal to 9 numbers to categorize the probabilities of all the sequences. So this assumption may be or may not be a valid assumption depending on the situation. Now let us see, given here, like we will use a simplified model here just with an example here. For example, let's arbitrarily pick some random numbers, okay, random probabilities. Let us assume that we pick up and put it like a probability of W, the weather of tomorrow given weather of today, can be expressed in this table. Okay, tomorrow's weather and today's weather. Like for example, today's weather is sunny, and what is the probability that tomorrow it will be sunny? It is 0.8 probability. For example, this is just only a random numbers that is given here, randomly fit out like this. Maybe like it can be, but this can also be derived from the previous history. If data set is available, you can derive this one. Okay, what is the probability of like today is sunny and tomorrow it will be sunny, or what is the probability of tomorrow being rainy given today is sunny? So the probability is 0.05. What is the probability of tomorrow being a foggy day given today is a sunny day? It is 0.15. Similarly, what is the probability of sunny given today is rainy? What is the probability of tomorrow is rainy given rainy? And what is the probability of foggy? Tomorrow is foggy, the given rainy. Similarly, what is the probability of sunny, rainy and foggy? Okay, different days given today is a foggy day. So this, let us try to do the probability for tomorrow's weather based on today's weather. Now this can be modeled using like that of a finite state automata, right? So for first order Markov models, we can use these probabilities to draw a probability finite state automation. So for the weather domain, you would have 3 states: sunny, rainy and foggy. That is what we are giving here. One is the sunny state, one is the foggy state, another one is the rainy state. And every day you would transit maybe like one state to another state, possibly that you may also stay in the same state, that also may happen. So the table what we have shown here, it can be modeled with a diagram here, finite state diagram. Okay, so now let us see about the problem. Like given that today is sunny, okay, today is a sunny day, what's the probability that tomorrow is sunny and the day after is rainy? Okay, you see here, please observe here, given that today is sunny, suppose today we are having sunny, it means, but you should remember that the previous probability is transition state diagram, you need to know it. Okay, suppose it is given to us and today is sunny, what is the probability that tomorrow is sunny and the day after is rainy? It means that you need to calculate about today is sunny, W1 is sunny, tomorrow is W2 is sunny and W3 equal to rainy. So this sequence, occurrence of this sequence, okay, we need to find out the probability of occurrence of this sequence. So that is nothing but you are giving it here like probability of W3 equal to rainy given W2 equal to sunny and W1 equal to sunny into probability of W2 equal to sunny given W1 equal to sunny. Fine. Okay, and that can be given like computed here, probability of using bigrams only. So you are not interested in trigrams here, so you are taking into bigrams. For the first line, what you can do is that probability of W3 equal to rainy given W2 equal to sunny into probability of W2 equal to sunny given W1 equal to weather on day 1, okay, weather on day 2, like that, W1 W2, that is the representation, and probability of probability of W3 equal to sunny given W2 equal to sunny into probability of W2 equal to sunny given W1 equal to sunny. So that is from the taking from the state transition diagram, you get these values, and the probability that today is sunny, tomorrow is sunny, and day after tomorrow is rainy is, what is the probability? Taking from the previous statistics, it is 0.04. Fine. This is how we try to get it. Okay. This is simply Markov models. Please, just we are speaking about only Markov models. Now, given that today is foggy, another problem we are going to see it. Given that today is foggy, what's the probability that it will be rainy 2 days from now? Okay, what is the probability that it will be rainy 2 days from now? Please remember that today is foggy. Okay, today is foggy. So 2 days from now, what will be? It will be rainy. What is the probability? It means that we are not given on the day which is on the middle. So it means that what they have given. So it may be, there may be different combinations, right? So we were given like a W1 is equal to foggy and W3 equal to rainy. But what about W2? W2 can happen anything. So here, if you see the different combinations here, it can be like this: foggy, and rainy. So in between, it may be so that W2 may be a foggy day, W2 may be a rainy day, or W2 may be a sunny day. Given first day means today is foggy and day after tomorrow is rainy day. So in between day is not given, so it may be any day. It may be a foggy day. The climate, the weather condition may occur like it may be a foggy, it may be a rainy, or it may be a sunny day, right? So therefore we have to sum over the paths, different paths we need to sum it up. So probability of W3 equal to rainy given W1 equal to foggy can be given as probability of W2 equal to foggy, comma W3 equal to rainy given W1 equal to foggy, plus probability of W2 equal to rainy and W3 equal to rainy given W1 equal to foggy, plus probability of W2 equal to sunny into followed by W3 equal to rainy given W1 equal to foggy. So that can be written as such. If you see here the probabilities, again you can write it like probability of W3 equal to rainy given W2 equal to foggy into probability of W2 equal to foggy given W1 equal to, so in terms of bigrams you are writing the earlier one, okay, plus probability of W3 equal to rainy given W2 equal to rainy and into probability of W2 equal to rainy given W1 equal to foggy. The day 1 should be foggy, day 2 should be rainy, plus probability of day 3 equal to rainy given day 2 is equal to sunny into probability of day 2 is equal to sunny given day 1 is equal to foggy. So this is, and simply substituting the values of from the state transition diagram, you are going to get 0.34. So what is the probability that today will be foggy and day after tomorrow it will be rainy? You are not bothered about the day in between. So what is the probability for that one? That is 0.34. Okay. Now you see. Now comes the hidden Markov model. Okay. Assume, suppose you were locked in a room for several days and you were asked about the weather outside. You should understand that there is only one piece of evidence that you have is like whether the person who came into your room carrying your daily meal is carrying an umbrella or not. And also some probability is associated with the person carrying the umbrella with him. And let us assume that probability of that person, the caretaker who is coming into your room to give you your daily meal is given like this. Like on a sunny day, he takes an umbrella with a probability 0.1. On a rainy day, he takes the umbrella with a probability 0.8. And on a foggy day, he takes the umbrella with a probability 0.3. You just imagine like this. Okay, please remember here the probability of the caretaker coming to your room who is taking you or bringing you an umbrella is this, the probability on different days of the weather, with the different weather conditions. And again, we need to remember about the Markov process, Markov chain, like a probability of W1 followed by W2, W3, W4, like to Wn is equal to probability of I equal to N. Okay, sorry, it is like a product of I equal to N, or it means to say that the product of all the bigrams in a sequence for that particular sequence probability of W1 to Wn, like that. So what is the probability? Okay, finding out, you please remember that these two equations, this equation. Okay, finding out the Markov process and the probability of the person bringing an umbrella. Now if you see here, we have to factor in the fact that the actual weather is hidden from you, right? You are not you are not able to find out, like see, suppose I say you that like the day one you are locked inside the room, and on day 2, day 3, day 4, day 5, day 6, like every day the caretaker is coming to you and feeding you the food or giving you the food, and on day 8 you see that what is the probability that you are interested in finding out that on day 8 it is so and so weather. So it may be raining, it may be sunny, it may be foggy. So how to find that one? So in between, the complete weather is locked from you and you are unaware of the fact. Suppose you do not know it. Only evidence that you are having is that you will try to take see that the person who is coming to you, he brings the umbrella, and also with some probability the person taking the umbrella, the caretaker taking the umbrella is associated with some probability with respect to the weather condition outside. Okay, so we do that. So we, what we try to do is that, let us see here the base rule. If you give it probability of W1, W3, W like the Wn, given that the like whether the person is taking like U1 umbrella on day 1, umbrella on day 2, like that umbrella in day 3, like that Un is equal to probability of U1, U2, U3, Un given Wn, W2, W3, like that on different weather conditions into probability of the sequence of the weather conditions occurring divided by the probability of taking the umbrella U1, U2, U3, U4 up to Un, like that. So here like what U1 is true if the caretaker brings an umbrella on day I, UI. Okay, UI is true if your caretaker brought an umbrella on day I, and false if the caretaker he didn't bring it. So the probability W1, W2, W3, like that, okay, is the same as the Markov model from the last what we have seen. And the probability of U1, U2, U3, U4, U5, like that up to Un is the prior probability of seeing a particular sequence of an umbrella events. Example, true, 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 or false, 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 like that. Okay, the probability here, like a probability U1, U2, U3, U4, Un given W1, W2, W3, W4, like that up to Wn can be estimated as the product of I equal to 1 to n probability of Ui given Wi. Let us assume that Ui is independent for all. Okay. Now suppose we are given here a equation, okay, or like a question is given to us like this. Suppose the day you were locked into the room is a sunny day. It was sunny. Okay, so you please remember on day 1 that you were locked into the room is a sunny day. The next day the caretaker carried an umbrella into the room. Let us assume that the prior probability of the caretaker taking an umbrella on any day is 0.5. Let us assume that. So what is the probability that the second day was rainy? What is the probability that second day is rainy? So here the problem is completely given here. Probability of W2 equal to rainy given W1 is equal to sunny, means first day was sunny and the second day is rainy, right? You are interested in finding out the probability on the second day, and U2 is equal to true. So that would be like probability of W2 equal to rainy and W1 is equal to sunny given U2 is equal to true, using base rule, the same thing that what we have seen earlier, okay? By probability of W1 equal to sunny given U2 is equal to true. And you have to remember that U2 and W1 means there is no connection between the second day taking a person. What is the probability of the occurrence of taking an umbrella, or what is the probability of a person taking an umbrella on the second day and the weather on the first day? So there is no link between them, okay? There is no connection. You please remember that they are independent in nature. Then so what you try to give here is that probability of W2 is equal to rainy given, or like and W1 is equal to sunny given U2 is equal to true given W1 is equal to sunny. So again there is no connection, that's why the denominator you have removed, that the second day taking an umbrella is a true, okay? You are not interested in. So simply by base rule what you try to do is that P of, so this is the complete equation, and if you see at the end, so simply solve it completely and then you try to find out this, substitute the values associated with, and then you are going to get, so probability of tomorrow getting a rainy day, being a rainy day, is 0.08. Fine. Now the same is given here, but with a little bit different way, okay? Or the problem is little bit more complex here. Suppose the day you were locked in the room, it was sunny. The caretaker brought in an umbrella on day 2, but not on day 3. Again, assuming that the prior probability of the caretaker bringing the umbrella is something around 0.5, what's the probability that it's foggy on day 3? Okay, foggy on day 3. So again, substituting the values, you give it like probability of W3 equal to F. Okay, foggy given W1 equal to sunny and U2 is equal to true and U3 is equal to false. In the second day he brought the umbrella and third day he did not bring the umbrella. This can be given like probability of W2 equal to foggy followed by W3 equal to foggy given W1 equal to sunny, U2 is equal to true and U3 equal to false, plus probability of W2 equal to rainy followed by W3 equal to foggy. You do not know whether the second day is rainy, foggy or sunny. That's why, okay, you have to do it. You have to find it out completely. Okay, probability of W2 equal to rainy followed by W3 equal to foggy given W1 equal to sunny, U2 is equal to true and U3 equal to false, plus probability of W2 equal to sunny, W3 equal to foggy. So you are finding out the third probability here. Okay, probability of W2 equal to sunny. It may be, as I said, you sunny, rainy or anything it may be. Foggy, rainy or sunny, right? So probability of W2 equal to sunny followed by W3 equal to foggy given W1 equal to sunny and U2 is equal to true, means the second day he has taken the umbrella, and U3 equal to false, it means that the third day he did not take the umbrella. So that is given with the equation like this, like probability of u3 equal to false given w3 equal to f false, and probability of u2 is equal to true given w2 equal to false into probability of w3 equal to false given w2 equal to false into probability of w2 equal to false given w1 is equal to, that is like what is w1 is equal to sunny, okay, plus divided by of course the other things like probability of u3 equal to false, and u3 third day he did not take the umbrella and the second day he took the umbrella, and the probability of w1 is equal to sunny, plus you are substituting the same for the above equations like that, and you are getting it the values and applying the Bayes theorem same, okay, with the conditional probabilities to the conditional probabilities and substituting the values, you are going to get the values. You may please calculate it, okay. I did not, due to lack of space, I did not compute that, okay. It is there down, it is there, but the visibility is not there for you. So what you try to do here is that let's again get away from umbrella and such for a moment and talk about the real things, into our speech recognition, or maybe like the occurrences of words. What is the next word that is going to occur or something like that. So in speech recognition or occurrence of the next word, suppose we give it on the Google and Google give something, type it on the Google and Google suggest us something like what is the best microphone in the market. Suppose I am interested to find out, okay, or who is the president of, suppose I give it, or Sachin, who is the best batsman, something like that. I type it on the Google, or you know that when you are typing something, some words are being recommended. How do we recommend that one? That is the same problem here. So in speech recognition, the basic idea is to find the most likely string, okay, of words given some acoustic input. So suppose I say I, okay, I, as I said you that, like what are the probable words, high probable words that may come into I am, I have, I was, like that, okay. Do you ever expect that the probability of the words IV occurrence is very very rare when you compare with I have or I was, like this, okay. So this or I am, like that, these are the words which has got high probability. So so when you need to compute the probability with respect to all the words, and here we have a argmax function. Argmax function basically tells us that, like, from the arguments, given arguments which is having the highest probability, you have to take that, okay. So argmax, this w belongs to word, means this word, particular word that you are belongs to the language L, probability of w given y, where w is the string of words and L is the language that you are interested in or speaking, and y is the set of acoustic vectors that you have got from your front end processor, okay. So to compare this to the weather example, the acoustics are the observations similar to the umbrella observations, and the words are similar to the weather on successive days. So here we say, like, right, we are trying to give it the same again, the basic equations for speech recognition using the like Bayes rule. If you see it, argmax of w which belongs to the language L, p of w given y can be given as argmax w belongs to L, p of y given w into p of w, sequence of the words or sequence of the acoustics given p of y. So for a single speech input, like one sentence, the acoustic y will be the constant, and therefore, so P of y also will be constant. Then in that case, what we need to find out is that, like, for a single input, so argmax w belongs to L can be given simply as P of y given w into P of w. So it is same like finding out what is the word, what is the probability that of occurring the word I into probability of the word occurring given I. So you need to find out argmax of this or any other word. I have, I, we, I, two, like this, okay? Or two given I, given I, have given I. What is the probability? So compute the probability and take the probability which has the highest maximum probability. So the first step of this expression is called the model likelihood, and second part of this called the prior probability of the word string. Fine, up to here. So the second part of the expression, like a probability of W, that is on equation 9, what we have seen, argmax W belongs to L, P of y given W into P of W. We are concerned with P of W, the prior, right? That is like the second part, okay? Here sometimes what we do is that this is like these two things, okay? This is the language model and this is the acoustic model. P of y given W is the language model and P of W is the acoustic model. Okay, now, so the prior probability P of W is the string of words that we are considering, and you please notice that we can have, or we can also replace this particular thing with the Markov model, like given in the following equation. P of W equal to product of I equal to 1 to n P of Wi given Wi minus 1. This is what we can do it with respect to a Markov model, right? Given here, see, there is an example given here. I like cabbages. So what is the probability of this string would be, probability of I like cabbages can be given as probability of I given the starting word into probability of like given I. It means that I followed by like, right? Into probability of cabbages given like. This is with respect to bigrams, okay? So this type of grammar is called the bigram grammar because occurrence of two words it is there, okay? And this is what is like what we are interested in about the hidden Markov model. Now you can please ask me queries if you are having it, any. Okay, I am stopping the recording and you may please ask me if any queries are there with you.